In this video, we will look at an indefinite integral whose integrand must first be simplified using long division. We will review the process of long division, then we will evaluate the integral. So the integral I have for you right now is this one that you see. We're going to integrate a rational expression, and if you notice, the degree of the numerator is greater than the degree of the denominator. So this expression is an improper fraction. And just to take it back a little bit, if you recall from grade school, when you have an improper fraction like 13/5, usually you can write that as a mixed number, and what you do is you take the 13 and you divide it by 5, and you say 5 goes into 13 twice, that's 10, and you have a 3, and we have a remainder of 3. The way we're writing this, we're going to rewrite as, remember we have 3 leftovers that still need to get divided by 5. So if we want to write this as a mixed number, we've got 2 3/5. We are going to essentially do the same thing with our improper fraction right here. So this is just kind of some prior knowledge to connect it to. The only difference is we are going to rewrite our improper fraction as 2 plus 3/5. So when we rewrite this rational expression, we will add on our remainder. All right, so you're going to see this process with a little bit more complicated math. And hopefully you've done this before, so this is a little bit of a reminder for you. So when you're looking at an integral and you see a rational expression, which is a polynomial divided by another polynomial, the first thing you want to do is look at the numerator and see if you do have an improper fraction or not. If the degree of the numerator is greater than or even equal to the degree of the denominator, you can use long division to simplify or rewrite this expression in another way. And that's what we're going to do. We're going to take our numerator, which is 3x squared minus 7, and we're going to divide it by 3x plus 2. Now when you do this, oh, there's an x there. Usually you want to include any missing terms. For example, we don't have a constant term, so I'm going to put a plus 0 here. If you have missing terms in between, you want to make sure you leave space for them. So our goal here is to match this first term. So we need to figure out what to multiply 3x by to get 3x squared. Well, if we multiply 3x by x, and we're going to put that above this column because this is where the x's go, we will be able to match this. So x times 3x is 3x squared, and x times 2 is a positive 2x. And remember, we're going to subtract this from what we've got. So if we do 3x squared minus 3x squared, we get 0, and negative 7x minus 2x is negative 9x. So we're going to ignore this 0. It doesn't matter anymore. We're going to bring down this next term because we have 2 terms here. And we're going to do the same thing. What do we need to multiply 3x by to match a negative 9x? So that's a negative 3. And we're going to distribute that, so we get negative 9x. Negative 3 times a positive 2 is minus 6. And again, we're going to subtract that. We get a 0 here, and we get a plus 6 here. This is our remainder. Now remember from the previous example we did, the remainder still needs to get divided by this 3x plus 2. So we are going to add that on. That 6 still needs to get divided by 3x plus 2. So we have divided our rational expression. This is our result. So now I can rewrite this integral as x minus 3 plus 6 divided by 3x plus 2 dx. And this is a lot easier to integrate. The integral of x is 1/2 x squared minus 3x, and then we have to deal with this integral. Now, I like to factor out the 6, so I'm going to turn this into 1, put the 6 out here, and because the degree of the denominator down here is now 1, and we have a constant in the numerator, this is going to turn into a natural log. So I have 6 times the natural log of the absolute value of 3x plus 2, but since I have this 3 in there, I need to multiply by 1/3, because if I take the derivative, I'm going to get that chain rule happening, which would be a times 3, so I need to multiply by a 1/3 to eliminate that result. And then don't forget your plus c. So we end up with this. If we simplify it completely, we're going to have a final answer of 1/2 x squared minus 3x plus 2 natural log of the absolute value of 3x plus 2 plus c. And we're done. I hope this makes sense. Make sure you always look at your integral before you start working on it to make sure you use the smartest technique for that particular problem.